Hi, my name is Alan. I am embedded system engineer at Espressif Brazil. Today, I will explain how I created a natural user interface game running on Nuttx RTOS. So, let's start the presentation. First of all, what is natural user interface? Conceptually, it's an invisible interface. That means we don't have some widget or physical button that user will press or will interact. It is more natural. That means that these interfaces are more natural for human beings. Uh, Example of this, we can say gesture, um, also the voice and uh, finger movement like uh, finger pinch to zoom in and zoom out interface. So currently we already use some kind of a natural interface in our normal life. The best example of natural user interface, or maybe the example most remembered, is the 20 years ago movie Minority Report, where Tom Cruise used some kind of infrared LED in his finger to control some kind of big screen, transparent screen, or holographic screen in a way. And he showed all the potential of this kind of interface. As a side note, there is a nice CNN report, CNN video about many technologies that Minority Report forecast more than 20 years ago. So what kind of devices you can use to create natural user interface? Some example, the simplest example is the Nintendo Remote, where you can use it to move movie screen, just moving your hand with this controller. Also the lip motion controller, where you can move your fingers and your hand in the screen and control windows or any kind of interface. Also the Microsoft Kinetic, it can detect the human body, and it can execute anything based on gestures on other features that user or developer decide to create. As I told before, the voice assistant device also can be an example of natural user interface. So when you interact with Alexa, actually you are using natural user interface. Also, the Nuttx screen, when you do zoom in or zoom out, you are also using natural user interface. And also for embedded system developers or enthusiasts, there is some low-cost gesture sensors like the APDS 9960 device. This device, I am using this device in this project. Here are the device that I talk about, the Wiimote and lip motion in all these devices. So how the idea started? Initially, I played with Android game more than 10 years ago called Shift Game. I installed the F-Droid repository to install open source applications, open source apps, and I found this nice game. It's like a mixture of Tetris with Crush Candy and also 2048 game. So in this game, you need to move the blocks to up, to down, to right, to left, and put the blocks with the same color together, and then they will disappear. They will be removed from the board, from the screen. So why to use Nuttx instead using Arduino or even some simple RTOS? Why to use Nuttx for this project? First of all, Nuttx is on POSIX and Linux-like RTOS. That means if I use it, I can create the program using Linux. I can develop the logic and the interface and so on using Linux. And then I will move to Nuttx. I just recompile it to Nuttx. So Nuttx has a video frame buffer, very similar to Linux. Also, it has input device interface, so I can use keyboard, joystick, or any other input device interface, just like Linux. And also, because Nuttx already had this gesture sensor integrated on it, so it was easy to validate and to test this application. My initial plans or initial thoughts was just 2 hours is enough to create this game. It's a very simple game. What could be difficult to do it? I didn't look or I didn't analyze the original game source code. So all the game was developed from scratch because I thought it just a very easy game. What could go wrong? So I can do it very easily. At least that was what I was thinking at that time. And the initial idea was, as I told, was to develop it on Linux, to test it without recompile in the firmware and flash the firmware and so on. I just use GCC to compile the C file and run it on Linux. So it was faster than Interact to do it all the time. And the initial idea was to develop it in test mode and then move it to frame buffer or to graphical interface. So idea was to focus on logic instead of focusing on interface or graphical interface. But when I started developing it in the first day, I faced many issues that I didn't imagine before starting it. For example, in the left side we have an example of the initial board game. So all the border of the edge of the matrix has some initial piece or an initial block. This block has a different color, and to identify what is the color, I used number to define it. Very simple. Just use 1 for red, 2 for yellow, 3 for blue, and so on. But when I start to move up, for example, if I press the move up key, it should move up, but it cannot remove the sail. It cannot remove the block that was inside the screen in the matrix originally. So in this example, if I move up, I need to I need to move the floor. For example, the number 2424 for the second floor, and the new floor will get a new values that will behind it, that is behind in another invisible layer, for example, and it cannot remove the cell of the matrix. And the same apply to walls and also to the floor. If I move down, I cannot remove the floor. So it was one of the first challenge to fix. It's not that difficult to fix, but I was surprised when I moved it and didn't realize it will move the block out of the screen initially. Also, the blocks move like some kind of directional gravity applied on it. For example, if the user press the arrows up, the key up, it need to move the blocks to the sail, to the up of the screen. But every time one block hits other or is near the other, it cannot overwrite it. So, for example, this number 1 need to move until it get in the sail in the number 3. But after that, the other number 1 that is two pieces or 2 cells behind it need to move to the next empty cell, and it cannot be overwritten. The other challenge that I have that I didn't go to it, but it's just a number here to say, oh, I have many challenges before get the game done. One of particular was when I start to search for horizontal lines. My initial plan was, if I found a horizontal line of the same blocks, I just go there and remove it. How I remove it? I write 0 on it. So 0 is an empty cell. But as you can see here, I face some issues when I did it, because when I remove a line in the second line, that could have some equivalent cell with the same color block. In this case, if I remove the first line, the same color cell in the second line will be in the game board. It will not be removed. So I need to figure out how to fix it. And I came up with simple idea. So instead of removing the value, write 0 it, zeroing it, I just turn it negative. For example, if I want to indicate that number 2 or block, the yellow block, needs to be removed, I turn it negative. So when I do the other tests, I will use the absolute value of the cell to compare. So when it tries to find some equivalent cells, it will realize the negative 2 is a valid cell and it's a congruent cell, and we will remove it. And the similar applies to vertical lines. So I did the same to the vertical lines. When I found vertical lines, I invert the signal. Just on detail here, when I search for horizontal line, I start from top and go down. When I search for vertical lines, I swap the matrix in moving in the same column, but navigating for each row by time. And when I finish it, I move to the next column and so on. This way I can find the vertical lines more easily. And finally, I just need to find the triplets, let's say triplets, so the three adjacent cells with the same block color and squares. So it's very easy. If I am in the first cell, I just verify if the next horizontal cell is the same color, and also in the next row is the same color, and also in the next row and the next column is also the same color. So I validate almost everything, but we are not done yet. That was only one that was missed in the original validation, and I spent some time to realize it, because normally during the test many other numbers or other blocks are removed first. So only I saw something similar to this one that's very clear. The inverted triplet was still in the game board, so I need to remove it. And internal joke, or not so internal, but I decided to make it a little bit more attractive before moving to the graphic mode. So I decided to replace numbers with the square colored blocks, and the border of the matrix I replaced it also to Unicode's grid to make it more easy to see and more nice to play, more enjoyable. So time to move to Nuttx. As expected, it was just a matter of recompile the code, and for my surprise, even the raw keyboard worked nicely. So the term I use that used on Linux to implement the get character to avoid pressing on keyboard and press enter. So I just press the arrow up and down, and it will work very nice. So the next step after getting the game working in test mode was to create the interface or integrate interface with the graphical LCD. But my idea was not to use LCD, but instead I was planning to use this RGB APA 102 matrix. Is a standard SPI RGB LEDs. So it's a little bit more expensive than the WS 8212, if I'm not wrong with the code. But it is better because I don't need to worry about the times and other signal integrity. It's just standard SPI. It's very easy to use. I don't need to worry about implementing a new interface or new standard. Just for curiosity, this other RGB, the low-cost RGB WS8212, is also supported on Nuttx, but I don't like to use this kind of timing to to control the device. I prefer to use standard interface like SPI. So the driver was very straightforward to implement, except it was zigzag. Normally, when we have an LCD screen or LCD display, normally after the end of the first line, it will start from the left to the right. But in this matrix, it is in zigzag because the last LED is connected directly to the near LED in the next line. So I just implemented this zigzag in the source code. I detect the row. If it is even row, I keep the normal buffer direction. If it's odd direction, if it's other row, sorry, I go in inverse direction. So instead of getting the buffer, then the column start from the column 0, I start from the last column and move it to the first column. And here's the LCD interface working. I will show now a small video to show it's running, as you can see here. As you saw, it was very fast, and now we can finally integrate everything. I use the ESP32C3 Rusty board developed by our friend Pedro Minatel. I integrate it with the RGB matrix and with the gesture sensor. Now I will show the demo of it working. Okay, let's start the demonstration. I will run the Shift application. And as you can see, it's a little bit difficult to see the LED colors because the LEDs are too bright. So I create this plastic frame with some paper in the top. Now it's easier to see the blocks. And now I will start playing the game. So if I move up, I put together the red blocks and they are eliminated because we have 3 blocks together. Same here, moving to the left, I put the green together. Also another cyan appeared and was removed. If I move down, I put these whites together. And same I can do if I move 2 times, I can eliminate more blocks. For example, these cyan blocks in the right. Move down again. So as you saw, it's a very, very nice, very strategic game. And sometimes it's better not to remove the current block and wait for the next next move to eliminate more blocks. And also it's very addictive game. So it's really nice to play. And I think it's a nice game to have in some hacker clubs, in maker clubs, maker offices, and so on. And that is it. So let's go back to presentation. As you saw in this demo, it is very interactive and very nice game to play. And I plan to create later some more integrated version with the LEDs and the ESP32C3 in the same board, and everything integrated in product. So these are the conclusion. My initial thought that just 2 hours was enough was totally wrong. I spent about 3 weekends fixing these bugs and getting everything working correctly. And it also proved that Nuttx is very Linux-like compatible. So I didn't spend time later porting it to Nuttx. It was just compiling and using the right interface on Nuttx. The original goal was reached, as you saw. I got everything working as I was initially willing to do. So, thank you very much. I hope you enjoy this presentation, this game. And if you have some questions or other comment, please let me know.
Okay, another amazing talk. And now I'd like to invite Alan from the lovely city of Florianópolis to join us. Boa tarde, Alan. How are you today?
Boa tarde, Pedro. I'm fine. And hello, everybody. And olá a todos do Brasil também. Muita gente aqui. Thank you.
Okay, so we have a couple of questions here. So I will start with Thiago. So does this game have audio? Like, of course, we didn't hear anything. So can you say if there is or any plans to add?
Yes, good question. Actually, when I start developing this game, our ESP32 chips on Nuttx didn't have support to audio, and recently we add audio support. So now it's possible to do that, and yes, it is in my plan to do some explosion, like when you put the blocks together, for example.
Nice. Okay, next question from Rodrigo. Is there an easy way to simulate this Nuttx game in Linux? Let's say I don't have the sensor, the display, how to emulate it, and how it works or how it works on its development?
Good question as well. Actually, as I told, I implemented it initially on Linux. So this game don't need to be emulated on Linux. It is just compile it, and the same game that works on Nuttx will work on Linux. So, but yes, it works only in the test mode. To use it like in the LED matrix, probably you need some USB SPI adapter on Linux to control the matrix. But yes, the game will work the same way.
Okay. Next question from Rodrigo. Have you tried using Walkway with Nuttx? Did you find any limitation?
I didn't try it yet, but I know some guys are using it, and also I think you comment about it yesterday. I think the base key is working, but they are facing some Wi-Fi integration issues that may probably, I hope Yurik help the Nuttx community to fix. Let's see. But I will try also to run Nuttx on the emulator. Let's see.
Okay, so we have one more question from Rodrigo. what's the major challenge you face along the development of this game application?
I think I faced many challenges as I explained. Most are very easy to fix, but I think the most difficult part was when I converted the text mode to graphic mode. Uh, so it was a little bit more complex because in text mode it was uh, just X and Y position, very simple. But in graphical mode, we need to skip some borders and a little bit more complex. And also, as I explained, this matrix is not a normal LCD. In Nuttx, we can emulate the LCD to get this matrix working like a normal LCD, but this part was implemented and it was a little bit tricky as well, but not so much difficult than the other parts.
Okay, so I think we have time for one more question, and I'd like to ask you is, how can I get started with Nuttx?
Yes, good question, Pedro. I think the way to get started, for example, is using the Nuttx channel that I created some years ago. Also, for people that don't speak in English, we have here in Brazil the Nuttx Brazil, also in YouTube. And I think Nuttx, just like Linux, was way more difficult in the past. Currently, it's very easy because now we can go in the nuttx.apache.org and get better documentation. We didn't have had any documentation or any good documentation in the past. Now there are many people using, and it is way more easier. And yes, I think the Nuttx channel is a good start point because there are many videos and many step by step to get it to work. Also here in Brazil, in Embarcados, we have a lot of tutorials from I think one very old from me and also from Sarah, from Gustavo. I think now Thiago and Pedro, also the other Pedro Bertolucci here in Brazil. Yeah, so I think our community is improving, so it's way more easy to get support on it. And also we have the Discord channel. I can pass the link in the chat later.
Please. Okay, great. Thank you so much for being here for the talk, and hope to see you soon.
Me too.
Have a nice day.
Good presentations for everybody.
Thank you.
Thank you.
Bye-bye.
Bye.
Sorry. Okay, so we have one more talk for today. This is from Microsoft, another external company that is here at the conference, and they will talk about over-the-air updates. So they will show us how to use that on Azure.